First, in this video, I want to talk about creating arrays. We've done a little bit of that, but I'm going to talk about two-dimensional arrays now. When you're creating arrays, you enclose the elements of the arrays in square brackets. You separate columns by either spaces or commas, and you separate rows by semicolons or the enter key. As with any other variable, you assign the array a name with the assignment operator, which looks like an equal sign. If you don't assign a name to it, MATLAB creates the name ANS for answer. Let's do an example next. B has 3 rows and 2 columns. To create this array, I give it a name, use the assignment operator to assign the values to that name. I need an open square bracket. Now I'm going to fill in the first row of the array, so 1, 2. I can put a comma here. Now this semicolon means that I move to the next row in the array. Those elements are 3 and 4. I can put a comma here if I want to, otherwise a space is just fine. Now another semicolon moves me down to the next row of the array. The elements of that are 5 and 6. The final square bracket closes the array. This will define this set of numbers within MATLAB's workspace. Now let's talk about doing arithmetic with arrays. MATLAB has 2 sets of operators. It has dotted operators and undotted operators. For the moment, we're only going to talk about the dotted versions of the operators. To perform addition and subtraction, the operators are the plus sign and the minus sign, as you'd probably expect. There isn't a different operator for addition and subtraction. These are not dotted, but they work exactly the way all the other dotted operators work. Multiplication is dot times. This is just the period sign on your keyboard. Division is dot slash and dot backslash. These will do the following operations. 3 dot slash 4. On the uphill side of this operator is the 3. That does 3 over 4. The other way around, 3 dot backslash 4 puts the 4 in the numerator because it's on the uphill side of this operator, so it's 4 over 3. Exponentiation is dot with a caret symbol. For dotted operators, the operations are done element by element. It's probably easiest to explain this with an example. If I want to multiply this array times this array using dot times, this element gets multiplied by this element and it's put in the corresponding array of the output. So 1 times 5 is equal to 5. 2 times 6 is equal to 12. 3 times 7 is equal to 21. And 4 times 8 is 32. A few notes on the dotted commands. Since these perform element by element operations, it implies that both of the arrays must be the same size. I can't perform an operation on corresponding elements if there isn't a corresponding element there. It also implies that the output array is going to be the same size as both of the input arrays. There's an exception. If one of the operands is a scalar, just a single number, that operation is applied to every element in the array. It can be useful to find out what the array sizes are in case we screw something up when we're defining the arrays. The size command returns the number of rows and the number of columns in an array. The number of rows will be the first argument, the number of columns will be the second argument. Now let's do a couple of examples of array operations. First, let's define a couple of arrays in MATLAB. I'll create an array A, open square bracket. The first row is going to be 1, 2. Then I'm going to go down to the next row with a semicolon, 3, and this time I'll use a comma and close the square brackets. So there's my array. I'll create a second array. B is equal to, open square bracket, 0, 2, 4, 5, 6, 1. You can mix up spaces and commas to separate columns. Also, it doesn't matter how many spaces you use. Array A has 2 rows and 2 columns. array B has 3 rows and 2 columns. If I try to multiply those together using the dot times operator, I get an error. It says the dimensions must agree. A and B need to have the same number of rows and columns. Likewise, if I try to add these arrays. Let me create another array C. So C is equal to, open square bracket, 0 space 1 semicolon, 2 space 4, close square bracket. Now A and C have the same number of rows and columns, so if I say D is equal to A dot times C, my result looks like this. Each element in D is the product of the corresponding elements in A and C. Now let's multiply C by a scalar. I'll name that E is equal to 3 dot times C. In this case, the elements in E are 3 times the corresponding elements in C. Now let's use the size command to determine the size of the matrix B. So, n row, comma, n col is equal to size of B. The size command returns the number of rows and the number of columns. In that order, they're returned as an array, which is why I define an array on the left-hand side. So, the number of rows of B is 3. The number of columns of B is 2. Let's take a look at B to make sure that's right. 3 rows, 2 columns. We're in good shape. Finally, let's talk about what are called script files. It can be awkward to work just at MATLAB's command prompt. If you make a mistake, you have to redo that command and any subsequent commands that depend on the one you made a mistake in. And once you exit MATLAB, there's no record of what you did. So MATLAB allows you to create what are called script files. Those script files contain a list or a program of the commands that you want to run. Script files have a .m extension. When you run a script file, the commands in the script file are executed exactly as if they were typed successively at the command prompt. Since these script files are a separate file from MATLAB, MATLAB needs to be able to find the file in order to run it. In order for MATLAB to find the file, I suggest you save your script files in the current working directory. So let's go to MATLAB now and I'll talk about what I mean by that. To create a script file, just click on New and select Script. This window will open up. You can type your commands directly in it. I'm going to do some checking out of the tangent of angles. So I want to create some angles in radians. So angle underscore rad is equal to 0, comma, pi over 4, comma, pi over 2, comma, and pi. Close square brackets. Then let's create some angles in degrees. Angle underscore DEG is equal to the angle in radians times 180 divided by pi, since there are 180 degrees in pi radians. Now let's take the tangent of the angles that are in radians. I'll call that tan underscore rad is equal to the tangent of angle underscore rad. Since the tangent command expects its argument to be in radians, I can use a different command to do tangent in degrees. So tan underscore DEG is equal to tan D, tangent in degrees, of angle underscore DEG. Now I want to calculate the difference between the tangents. So I'll call that error, and that's just tan underscore rad minus tan underscore DEG. Now I need to save the file. So I'll save it. I'll name it test1. Notice that test 1 now appears here in the current folder window. MATLAB always looks in the current folder first for a file to run. The path to the current folder is shown up here. If you want to change that path, you can browse to a new location. Now to run the file, click on Run. The file runs and here are my results. There's my angle in radians and my angle in degrees. My tangents in radians and degrees, which are kind of interesting. The tangent of 90 degrees should be infinity. I'm getting a huge number, 1.63 times 10 to the 16th when I look at radians. That's probably due to round-off error. In degrees, I get an INF, which just means that the result of the calculation was bigger than the biggest number that MATLAB knows. For the errors, they are very small, 1 times 10 to the minus 15th. The exception is this guy here. If you use infinity to subtract anything from, you still get infinity, so I've got a huge error there still.